בוקר טוב. תגיד, זה יכול להיות שאני ראיתי אותך במחוז בעיה דיונים? לא משגתי, איפה? אתה רואה, יש אנשים שאני פוגש אותם, יש אחד שפגשתי אותו רק שאספתי את המזוודה שלי בבן גוריון בדרך חזרה, ואחד אני פוגש שבועיים אחרי הכנס. כי היינו בלי שאני לא עושה לחוק, יש את המקומות שמדריקות עליי שיורדות, ולאגע כל הציבור שיורדות לכיוון שמצד צבוע האקסיבישן. אז ראיתי אותך שם, היה לי בלי שאני ראיתי אותך יושב, והאוסן שירדתי למטה נעלם, חשבתי שאתה מגיע על הרצפה, בדיוק. שמע, אני שרות שלו היה ג'יופי. זה עושה כל פעם. אני לא מספיק רחוק. אבל אני לא מכין את ההיסטוריה שלך. מה מכין ריק? בסדר. בסדר, נראה אותך בתור בסיק סמינר, וסוף סוף אני בנה לכם למי שבאמת בנה את זה בקבלנו. הנה, ניקולוטי יכול להציג אותו, אותו ניקולוטי, הוא אומר שלא אתה יכול להציג אותו. אז אמרתי שיגיד, הנה סוף סוף יש את הבן אדם שבאמת בנה את זה בקבלנו. איפה זה היה בקבלנו? לא יודע מה זה.
מה זה עושה?
לא יודע, גם אני לא יודע מה הוא חבר, אבל מה אתה מתכוון? אתה לא יודע, על איזה קבלנו? אתה לא צריך לבחון המוסד של הגישות של חיבר? כביש טבריה צמח? אני מדבר על היסטוריה. כביש טבריה, תשאל אותו מה זה כביש טבריה צמח.
בקיצור,
39 שנה בסורק.
בסורק מה?
מרמר.
מה זה?
אומר ככה, ב-39 שנה, אחר כך עוד 40 שנה, אתה רוצה אני אציג אותו. לא.
יאללה קדימה, אין בעיה. בבקשה מוטי.
לא.
למה לא?
ישו יותר קרוב ממני. לאיזה קבלה לא?
הכל בסדר.
זה הכל יחזיק כביש בין הצמח. לא? צמצמת פה. למה? זה יושב כאן. אני יושב כאן. אני מקצר שבח אני מקצר
למה יש לך נושא? אולי רגע אם נעשו זה חק, יש לו רגע
ככה הוא נראה שלך, אני אומר
אתה אומר לנו
לא עושים היסטוריה אני אמרתי לך תראה, בקים לשמוע אותך בשורה הראשונה היית אמרת את זה? שתיים אני לא יודע מה זה כביש
אם אתה לוקח גם את הנושא, אז אתה לא בטח עמוס.
אבל זה לא נכון להציג אותו ככה 40 שנה רק עוד 20 שנה
מאז שאני מכיר אותו הוא לא עבד על זה
הוא לא עבד על זה זהו, שאתה לא יודע, מה זאת הבעיה?
לא, הדבר היחיד שהיה חשוב זה היה המון.
גלץ הזאת גלץ הזאת צבאית, ראית מה קרה
אתה רואה מה קורה עכשיו?
אז אמרתי לו,
אז אני שם את זה במקום בסגאי. הרבה יותר טובה.
אתה יודע מה אני מצאתי שעבדי טוב בוואטסאפ.
בדיוק,
לא, אבל אתה זום, כל הבנקים, בו זמנים.
הכל מקום
לא בסקייפ.
גם בסקייפ החדש.
בסקייפ אתה יכול לדבר בינתיים.
בדיוק, מתי אתה יכול
רק אם אתה משלם.
לא, לא משנה, רק אם יש לך לא משנה. תשמע, יש להם יותר גדולים, מה שקרה שם. למה רק אתה שומע? אתה לא שומע טוב. יאללה, תבוא שומע אחת אחורה. שאין לו מה להגיד, עכשיו תשמע.
אוקיי. I'm glad that all of you are here. We have the Proverbs of Fredy, Proverbs of Fredy from the Geological Survey of Israel. I'm not, well, it's the first time that I meet the Proverb. I'm not sure how to represent it. And then people told me that I shouldn't talk about this book because some of it is secret. But today he's going to talk about radon and carbon dioxide as proxies for seismic activity and earthquakes. Okay.
Shut up. I'm very dedicated. I have a lot of friends here. I think that most of them does not need my information to know who is Herrmann. In any case, I really spent 39 years in Sorek, in research and applied research really. I work a lot with people from the Geological Survey. While I became an emeritus, I was very glad to do it in the Geological Survey, with Fredy and Nadine. And what I'm going to describe here is the probability to use radon and CO2 in depth as a proxy for pre-seismic activity. You will judge if our ideas really work or not. I will begin with basic evidence or basic technology and the methods that we are utilizing. We are doing the use of the radon radioactive decay in long-term underground. So the basic evidence is that the radon is the only gas element in the one-year decay series. Therefore, it can move while it's arrived to the host media. It can move under the thermodynamic driving forces for a long distance according to the half-life, which is about 3.5.
יש מישהו פה בקהל שצריך להגיד.
אני שאלתי את יעקב, הוא לא רצה לוותר לי. אין אף אחד שמדבר אנגלית. אני מוכן לרוץ, אני לא רציתי לוותר על הרוסית. אתם תמכי ברוסית.
John Moore.
Okay. John Moore, from your English, Boston.
Working to understand your English. Yes.
Okay. In any case, you can see that if we want to monitor the radon, we have two possibilities. or to counting the alpha radiation emitting during the decay line. And you can see these three possibilities to get alpha from the radon while it's decay, or to measure the gamma radiation emitting in specific gamma energy that we can measure in this transition from lead 214 to via bismuth to polonium. I will show you that it's a real, there is a real fundamental difference between these two possibilities. In any case, what we have done for a long time is to calibrate different type of sensors. And this is an experiment that we have done in the tunnel of Herrmann. It's a closed space that we can really believe that we can get an equilibrium between the radon inside in the airspace and the radon on the walls. And you can see, without to be experts with nuclear detectors, the difference. The main difference that you see, the main difference is that you have here 5 different type of gamma sensors. You have here a calibrated in kilobecquerel per cubic meter of ionization chamber. This is the system. And this enables us to really calibrate the different type of the sensors. And the main comparison is with the alpha detectors. And you see that the low resolution in time of this sensor, that if you don't summarize the results for at least 5 hours, you will not see these sharp changes in the radon concentration in the place that you are measuring. In any case, we know that the difference in sensitivity is about 3 orders of magnitude between the gamma sensors and the alpha sensors. But I will show you why we're still using them both. The configuration that we choose to monitor the radon is take measurements to a depth. But we believe that the influence of the climatic parameters as temperature and pressure are really reduced with the depth because the energy cannot penetrate to the depth of tens of meters. The configuration include gamma sensor in different depths. This is 10 meter depth, this is 60 meter depth, and the lower one lowered to a depth of 88 meters, and at the beginning it was submerged in the groundwater. In the middle of 2016, because of overpumping in the Hula Valley, the water reduced lower than 100 meters. So this sensor became exposed also to the radon radiation from the surrounding. In the middle, we have another alpha detector, and now I begin to explain why we use both of them. The basic assumption is that the gamma sensor really measures the gammas that penetrate 35 centimeters and can reach the detector and give the capability to measure changes, temporal changes of the radon during time. While the sensor, the alpha sensor inside, because it's required that the radon will reach it, and the range of the alpha particles in the air is only 4 centimeters, the only capability to measure radon is to allow the radon to enter the sensing volume of the alpha detector, and it means that measuring the sensing volume is not more than 50 cubic centimeters. While if we calculated, for example, in this well which has a diameter of 50 centimeter, then if you calculated the contribution from the surrounding, you can find that there is about 1.5 cubic meter that contribute gamma to the sensor inside. In general, what we know is that the gamma detector sees the radon outside of the casing. And the radon outside does not know that there is a big pore on the side, which include the gamma sensor. So all what happened outside, it's independent of our method of measuring it. While in the middle, we get a complementary information about the streaming of the radon in an open casing, and the only possibility of radon to enter this airspace is coming from down, because you know that the boundary condition of radon on the surface is zero. We assume that radon really disappears in the air, and it cannot return back from the surface level. Now, this is the final configuration after we had CO2 sensors, and we decided to do the same logic of spreading the depth with the sensor. So, and we have two sites, one in the node, in Eliezer. It's a abundance well that we found located in the western side of the main Dead Sea fault. And the other one located in the entrance to Nahal Mor, which locating in the front of the Lisan in the Dead Sea. This is the shallower well, which reaches only 47 meters. In any case, we put a 3 CO2 sensor here in 40 meter, in depth of 40 meter, 20 meter, and 5 meter. And in this case, in the Galil, in the Hula Valley, we lowered one CO2 to 70 meter, 40 meter, 20 meter, and 5 meter. And what I will present is the work of the results that we really collected for the last 5 years. Okay, this is the deployment of our stations. You can see in the north the place of the Eliezer site, and in the south this is the place of the Nahal Mor site. First, I will show you the results that connecting the radon behavior with the climatic parameters, the temperature and the pressure. I called it, and think that this graph really presents the normal, the common, and the expected radon behavior in depth of any drilling, not only this one. So what you can see, this is a time series of 4 days. The dotted line presents the midday, the full line presents the midnight. And you can see that we have two types of radon signals that we can measure in any place independent with time. What you can see is, we can begin with the lower signals, that you can see that it's reached the maximum just between 4 and 6 a.m. in the morning. And the other type is the signals that we got designed with stars. These signals really appear in afternoon. We believe that the driving force is the temperature outside. You can see that the temperature here get maximum about 2 o'clock p.m. And then we got first radio signal here at depth of 10 meters, and then another signal in the middle in the airspace, and then we get another signal in the leg of time that you can really see it, and I will show you how we can measure it directly, which means that under the influence of the temperature, afternoon, we reach these 3 signals that describe what happened to the radon outside. And the meaning is that radon first, on the surface, we got the maximum temperature, then we got a peak in the radon. First, in 10 meters, after 2 hours, we got a peak in the signal here, and in between, we have a signal inside. Okay.
What is the second peak? One peak in the afternoon. You have also peak in the morning.
This is what I am saying, that we have 2 types of signal. Appears a lower signals that appears, sometimes appears and sometimes not. But usually you expect to see them. They are lower in amplitude from those signals that appear afternoon. I will explain what is the reason that we have 2 types. At least you can see that these lower signals has anti-correlation with the barometric pressure outside that has minimum at the morning, and this minimum in the barometric pressure come from what people call atmospheric tides. It's part of the phenomena that come out because of the circulation of the Earth. And the second one, as I say, and I will show it now, that it comes from the influence of the outside the temperature on the surface. In order to convince you that this is an calculating, averaging, and presenting the daily distributions of these parameters. So on the top, you can see in purple the radon behavior in 10 meters. This is the radon behavior on 60. At 60 meters, this is the temperature that we think that it's the driving force that caused, in this case, the appearance of this maximum. The difference in time, the average difference in time is about 2 hours. The depth is 50 meters. So if you believe, and you believe my explanation, that it's caused because of the streaming of the radon down, then it's the first measurement of radon velocity in the natural media, which is 25 meters per hour.
Is there an earth tide signal that you can pick up?
I don't believe that you see. I can tell you that only one that we have done a measurements for a long time in Iraq, close to there was an IUI well to a depth of 2 or 3 meters, and we really hold over there gamma sensors, and we saw the tides.
This is the stick tide. Not
I'm talking about earth tide. I mean, if you put a gravity meter there, you would find.
Outside, nobody really connected to radon, but on the other side, as we thought, the sea tides we saw. So I'm not sure, but we never saw any connection to or modulation of the amplitude of the radon signals by air tides. In any case, at least this is one thing that came out is the capability to measure the radon velocity in the natural surrounding. The fourth one is the barometric pressure. And this is the behavior of the radar signal in the airspace of the building itself. And at least we show that the maximum that we reach in this case really depend on the negative gradients of pressure, which really agree with the model that if you are familiar with it, and it's a very general model, and it exists for more than 40 years, at least it says that radon concentration in the porous media can change by difference in concentrations. This is the gradient of the concentration in different type of porous media. The other parameter is the dependency with the gradients of pressure, which I show here. And you can see that the maximum in the radon here is along the gradient, not on the top of the minimum of the pressure itself. What I'm adding for more than 15 years is this phrase that still today there is no additional feature to this equation that will describe the changes in the concentration of radon under the influence of temperature. Remember it because I will show you that in the next slides that it's not, at least it's not linear effect. So it's too complicated. This is the reason that why there is no model that describes the intensity between radon movements and the temperature of driving force.
But excuse me. The temperature forcing should be should give you a velocity, an advection velocity, or some
yes, but
which comes into that equation, which is
yes, but
another
you have to remember that the temperature operates only on the surface. So it's like to boil water in a jar. It's give the radon the energy to move, but it does not work along the 100 meter that we can find, where we can find radon after this signal.
So the temperature operates, you're saying only on the radon, or it operates, the radon is a tracer for
temperature, I will show the speed, but the temperature really gave energy to the radon on the surface in the first 1 meter.
Temperature always gives gradients of temperature always allow flow. All fluids flow into gradient.
Okay, all the rest depends on the capability of radon because it's a heavy element to move with the high velocity and mass that enable it to go down to 100 meters, which is very, for me, it's very simple. For the others, it was, I think it's a revolution because it saved me a lot of time to convince people that this is, because I asked for another explanation. If anybody else has an explanation, how would we got this peaks of the radon and depth of 60 and 88 meters? I'm ready to hear. In any case, this is the normal behavior of all the parameters in the frequency domain. The units, because it's calculated for signals in 30 seconds, so the numbers doesn't. I really have to change the scale, but it does not matter. This is the temperature that has a peak once every day. This is the pressure that has two types, S1 and S2. And this is the influence of both parameters on the CO2, again giving two signals, two periodicities for the CO2 as well as for the radon, and you can see that they are very similar, which means that the thermodynamics does not care if one of the elements is heavy and radioactive and the other lighter. This is the concept that we believe how it works. Outside, you see the gradient of temperature really force the radon to move down. And if at evening the temperature of the ground became a little higher than the outside, then the streaming is in opposite direction. In connecting to the barometric pressure, it's work opposite. If you increase the gradient, then it's prevent the radon to enter the system. If there is a decreasing in the gradient, you have a negative gradient, then it's allowed the radon to go up. And I think that the people from the CO2 call it barometric pumping. Okay. Now, after this explanation, I think that we are ready to understand the connection between all these parameters. Okay, first, this is the results of the first 2.5 years that we took measurements in the north. Again, you have all the parameters in one graph. The green is the temperature, the dark red is the barometric pressure. This is the measurements of radon. The depth of 10 meters, 40 meters inside the airspace, 60 meters outside, and this is 88, and I told you, while the water went down, then it began to behave like those two. And on the bottom, you can see for this period of time, about 200 earthquakes that appear in this map coming from the physical survey. And I chose to show you at least 3 cases that we found the correlation between radon and the earthquake. The first one happened on 2015. You can see that the day before this earthquake that appeared in Nueva, and it was with magnitude of 5.5, we got some anomalous signal, not with the amplitude, but with the time scale. So we think that we got 24 hours notice that may be connected to the appearance of this earthquake, and because it was abnormal, we think that it's connected to the energy that released. Don't think that the radon really moved from Weber to these daily sites. We think generally that the release of stress or strain with the energy of this earthquake, maybe it's really changed something of in the local surrounding at the laser, which squeeze radon from side to side. So this is maybe the reason why we got such a broadening line. We make interpretation in producing a spectrogram which connect all together the temporal dimension here, the frequency dimension here, And you see that the system can pick, the mathematical system can pick these anomalies very easily. Even if we can see it without these methods, but it's only to prove that it's a real Bohodian environment. And it's even pick up also another one that appeared very, very low, about three weeks before. So we don't have yet any interpretation except that we see connection between this pre-seismic process that releases stress and strain along the faults. Maybe it's the reason why we got this anomaly. And we have another, and this is the mathematics in order to be honest with you, so as well. And this one, it's another three anomalous signals that we found with, you see this few earthquake that was with a magnitude of between 2 and 3.2. But the connection is that all this, except this one, the Dead Sea, HUK is a full itinerant area, and there are very low, but the station is very close, less than 40 kilometers. These places, the center of the earthquake. And again, the synthetic work can really pinpoint broadening of the lines. Another case was a year after, another earthquake in Nueva area. It was only 5.1, but it's a really big one. And again, we find three broadening signals before the earthquake. This one, you can see here that it's covered at least from the 24 hours, it covered at least 40 hours before the earthquake itself. The third one was that was lower in energy but closer. Palmyra in Syria, really situated on one of the branches of the main Dead Sea fault zone. And we found, you see, two anomalies. One is 7 days before, the other is 2 days before, and this one really was wide, broad, and again, it's more pronounced in the deepest sensor, which means that the assumption that if we will go down and we will get rid from the influence of the atmosphere outside, in this example, you can see that on the top, you see nothing. And this is a proof, you know, people in the radon business believe, because of an example of very famous earthquake in Tokyo, in Kobo, in Japan, that the expected radon signal that has to serve as a precursor or early warning has to be with a large amplitude. And we think that maybe if the earthquake will be 7.2, maybe it will be a huge signal. Meanwhile, what you really believe that any extension of stress, strain, or even movements really cause this broadening in time, not in amplitude. I'm going almost coming to the end. We decide to add CO2 because we thought that thermodynamically they are similar, but not matter. So we had this. This is the results that we took in 2018 at Sderry Hazard, and you can see all the radon that measuring. outside the casing by the gamma sensors. You can see the shift, the lag time between the upper one and the lower one. Here you see the alpha or the radon inside the casing, and this is the results of the CO2 at 70 meter, 40 meter, 20 meter, and 5 meter. And at least you see that all these gases behave the same under the influence of the driving forces. Does not matter if it's the temperature or the pressure, if the barometric pumping or anything inside. But what we know, outside, the radon really streaming down. And this is the supply source for the radon in the water that return back while the barometric pressure enable it to climb in the well. And the people from the CO2 range, from Zuckerberg Institute in Zebuker, really calculated and come to conclusion that open wells like this really serve as sources for CO2 streaming to the atmosphere, which is another contribution from our nuclear power. They published it, and it's something that it's improved a few weeks ago. Now, I got the support from this case that happened in 2023, this emergence of seismic events in the Kinneret in 40 days, 45 days. And you see a sample of 107 earthquake with an amplitude, with magnitude not more than 4.5, two of them in the blue here. And we decided to check, because this upgrade our statistics. Really say all the time what we have in order to prove our assumption is to pray to have the biggest earthquake in Israel on the Dead Sea Faults. But if there is a chance to get better way to get statistics, this is one of them. So I will show you what we really measured in this situation, and this is again the entire measurement from the beginning of June to the almost end of August. And all these swarms are coming, arrived only from earthquakes at that point, at the bottom of the Kinneret. And you can see, again, I say without mathematics, without modeling, you see here some places a broadening signal. Okay? A depth of 88, 60 meter, 50 meter, and inside the casing itself. Here is the temperature of grain, and this is the pressure. What we found that we got about 9 sections that we have broadening of the signals, which again show us that there is a connection, although because of the mainly because of the low and lower magnitude of all these earthquakes, they are not connected. We don't know to say what's the real connection between these. We think that at least the gases, radon and CO2, really react to the press seismic process. This is what we think. So if you want to see detail, I will show you only the the editing of this G and H. And now you can see again these two broadening over 24 hours. This is the spreading of the between the earthquakes, which really make a confusion because we don't know exactly who connects to whom. But at least we see that it shows maybe what happened at depth because of tectonic activity. And you can see here that the CO2 in 40, even in 20 liters, really react the same. Thing that was important from this result is two things. First, we believe, it's very natural, that we believe that these results may still consider preliminary, but they do strengthen our contention that radon, when measured and understood properly, this is the main basic assumption. Understood properly is a precursor to pre-seismic event. Does not matter if any one of these pre-seismic events ends with rupture or not. Does not matter. And we don't know yet to really to convert it to numbers, to prediction, nothing, except that we believe that it's gas. And it does not matter which type of gas we could use in this case, which means that the principle of taking measurements in depth, you can use any type of gas, and it's the requirements that we recommended in the abstract. You could see that the last section was the recommendation how to work with this assumption. First, to choose a drilling that is situated, that located along the fault, active fault. Second, take a preliminary measurements to see if there are gases enriched, because for our luck, more than our brain, the phenomena that we discover in this site, the nodes, really, we found both gases, the radon and the CO2, enriched to a level that our technology, our detectors can measure the variation in concentration with time in very accurate manner, which help us to at least to begin to understand what is the procedure. And again, it does not matter. Maybe there will be methane or even oxygen or NO2 in all or any natural gases. It does not matter. You can find in specific boreholes along active faults can work. That's all. Thank you.
Well, thank you very much.
יכול לענות בעברית או גם באנגלית?
מה שאתה רוצה.
רק עם ג'וני שם.
Have you tried to get the artificial intelligence people interested in these data sets?
I'm working now in Barian University too. So the group over there really good to send to students. Try, but I told you, as an experimentalist, I don't care. Why? Because I see it in my eyes. I look at the weekly results and I can identify if it's normal, common, expected, or we have an anomaly.
That's after the fact. The artificial intelligence might be give you
I
a
agree. I don't
precursor
have to
model.
work as a machine.
Yes, sure.
Did you have any events of broadening of the radon or CO2 signal without an earthquake?
No. Only that you could find in the surrounding.
Or
we did not find any broadening that come from the air.
no, but did you have broadening with earthquake 2.1?
I told you, only if it was designed as Fula Kinneret or Golan Heights, then we saw the connection. Which is very similar to what we measured in the Kinneret. So only close and low really influence. And we know. So the same statistics, this is what I'm saying. I have to play too much.
It would be quite convincing if you had a plot in which you you plotted broadening event and versus or the amount of broadening and which you can somehow quantify versus the delta time to the earthquake or delta distance to the earthquake. If you could quantify it, because you have such a variability. Sometimes it's 7 days, sometimes it's 4 hours, sometimes, and then you have you have to somehow quantify it because there would be a time when normally you could say it's like 2 weeks or 3 weeks, and when is it connected to an earthquake?
What we try to do now is to make cooperation with people who are sitting in areas that most of the earthquakes are with higher energy. Central part of Italy, the St. Andreas in the States, we really submitted a proposal to the NSF, BSF, denied, okay, it's part of our efforts. But we really want to do it. Another thing to do is to add independent geophysical method to this system. And now we are going this is the reason why we cooperate with Ariel and Herrmann. From Ariel, they have the capability to make electromagnetic measurements by implementing what we call search points. So that can measure changes of magnetic fields with very low frequencies. This is what we want because it's not frequency, it's some type of sequence that it's random. So this one and the other technology come from Bar-Ilan University is to buried optical fibers. Now the optical fibers can
To measure strain.
to measure the changes, the local changes in strain and stress and maybe movements. The technology now, and this is the reason why we almost met in the AGU, some group in one of the American universities developed the technology to get resolution. The required resolution is better than 10 to minus 9 strain. They got a resolution of 10 to minus 15. So it's an experimental. We spoke with them. I hope that maybe we could, they say that they are going to sell system in 20,000.
Cloud from Technion also has a very high resolution with optic fibers for it.
I'm familiar with
גם, חשבתי שה-CO2 נראה יותר רגיש מאשר רדיום, לפי מה שראיתי בגרף, אתה רואה פיקים ב-CO2 שאתה בקושי רואה אותם ברדיום, אתה רואה אותם יפה ב-CO2.
אתה צודק, ואני רוצה להגיד לך שזה לא סתם, השיטה הזאת של לשים אותם בגבהים שונים, אפשרה להם בתוצאה משדה בוקר לחשב את מהירות הזרימה בגלל דיקי, כשהלחץ עולה, אז הם בבת אחת נופלים. אז הם חישבו את מהירות הזרימה, ואני חושב שזה משהו כמו עד 3 מטר דקה. לעומת 25 מטר לשעה, שלוקח לרבון, לגרום בתוך הפורוזמנית.
I just have a question about the application of the method. Let's say that it works, yeah? It gives a warning of about 2 days, according to what you plotted, before an earthquake.
I cannot say 2 days.
No, 2 days is a lot.
We choose this criteria of 20, 24 hours before, or broadening of 20, 24 hours. It's not accurate, and it's not early warning. It's mainly precursor.
Thank you very much.
מה שמזכיר לי